Okay, so again, so this runway has 27. So now, how many of you know how to read a compass? What is this direction? North, right? North, east, south, west. So when we say, now do we know, we also use degrees for north, south, east, and west? What's the degree for north? North is 0. So this is a difference right here. Okay, when we say, this is what we call bearing. Okay, when we say, all right, you're going to travel 0 degree, direction is 0 degree, that means you are traveling north. Now that is different from what we use for our quadrants. Like quadrants 1, 2, 3, 4, we have the 0 on the right hand side. But for bearing, when we tell directions, north is your 0. So now, why is it 27? Now in aviation, we actually drop the last digit, the ones digit, because it's not very meaningful and we want to cut it short. So when we see 27, it actually means 270 degrees, which is this way, west. So you're heading west at 270 degrees. So you're landing this runway 27, meaning that the runway is pointing to 270 degrees. And that explains why the other end of the runway says 9, because it is pointing at east at 90 degrees. Okay, now let's take a look at the other runway here. So now, before we look into it, so this runway is pointing to this direction. Can you guess how many degrees around? 100 and 135. Now we always like to put it in the round to the 0 because we don't express the ones digit. So we say 130 or so, maybe 13. So let's go ahead and zoom in and see what number is printed here. It is 15. So close enough. Okay, so this is 150 degrees. And can you see the R right here? Do you know what the R stands for? I mean, what could R stand for in navigation? Right. And there's a left. So you would know that, oh, I'm landing on the right hand side of the runway, okay, or the left hand side of the runway, and that's how you would know which way to land or take off. Now, if this is 15 on this end, what is the number on the opposite end of this runway? Think about it, okay? If this is 15, what is the number on the opposite end of this runway? Now 5 would be this way. Now think about degrees first. This is 150. What is this direction? You can draw it out, draw it on the paper. On the back side, there's a lot of blank space. Okay, draw the 150 and then extend it on the opposite direction. What is that angle? Well, it'll be 30 degrees away from 360, which will be 330. So on the runway, it will be painted as 33. Okay, that's runway 33. So I'm not sure if you were ever curious about it. So when I was during the pandemic, I couldn't fly a lot. So I played a game that's airplane simulation. So you have to land or take off an airplane. The sound is pretty soothing. It's noisy, but it's kind of soothing. The engine sounds, and then I learned more about these airplane stuff. Yeah, so that's something, just something you can learn from the traveling and aviation stuff. So again, you can go ahead and draw this on the upper right-hand corner. if you read a compass, this is north, and north is how many degrees again? That is 0 degrees. Okay, so east would be 90 degrees, south would be 180, and west would be 270 degrees. Okay, so north, south, east, and west. Okay, north it's 0 degrees. So that's how we do bearing. Now we have 3 examples to go through today. It's very straightforward. It's very easy. Okay, so we have a ship that sails 100 kilometers east. Okay, so let's just say we put a dot right here. It sails 100 kilometers east. Now, when we do this kind of drawing, try to be when you draw the arrows, keep the relativity. Okay, how this is 100 kilometers. Then when you draw the 40 kilometers, you'll be like somewhat shorter, like half as short at least. And then you would go ahead, draw a little cross here, right here, because it's going to make a turn. It's going to travel at 120 degrees for 40 kilometers. So this is 40 kilometers, and this is 120 degrees. Okay. So it's asking 2 questions here. It's asking how far is the ship from its starting point, and what is the bearing of the ship from its starting point. Okay. So we want to find out how long this is. Okay, how far it is from here, from the starting point. And we also like to find out, what is this bearing? What's the direction? What is the direction of this new position from the starting point? What is the new position from its starting point? Okay. All right. So well, we have 2 sides. We have this 120 degrees. So can we tell this angle? What is this angle here? It is what? Is what? 60? That's more than 60. But it's related to 60. Because if that's 120, well, this is 60. And this is 90. So all together would be 150 degrees. Okay. Again, we're given the 120. So the remaining part right here, from here to south, it's 60 degrees. And this is east, right? So this little angle right here is a right angle. It's 90 degrees. So 90 plus 60 is 150. So we got 2 sides and 1 angle given, and you're looking for the 3rd side, the remaining side. That means we are going to use law of cosine to find it out. So we have 100 square plus 40 square minus 2 times 100 times 40, cosine of 150 degrees. Okay, so get a calculator if you need to, and go ahead and find out what x is. Okay, so if you do everything properly, well, let me get my answer to 100 square plus 40 square, and then minus 2 times 100 times 40 times cosine of 150. I got a number, like 18,000 number, and then I would square root that number. So I get x equals to 136.118 kilometers. Okay. So which would make sense because you're going 100 kilometers to the right, and then 40 kilometers is going down. So yeah, somewhere right there, 136. Okay. So that's the distance. And now we say, well, what about the bearing? what about this little theta thing right here? Okay. So it's kind of hard to find out this by itself, but we have a triangle. So if we have a triangle, we can do something about this triangle and to find out this overall theta, because with a triangle, we can find out this particular angle here. Okay. And let's call it theta prime for the moment. Okay, let's call it theta prime for the moment. And could you find out the measurement of theta prime? What would you use to find out the theta prime in this case? The law of sines, right? So I would do sine theta prime over 40 kilometers, and you will inevitably use the information you just got. So you have sine of 150 degrees over 136.118. So you will go ahead and find out the theta prime. So here, sine of 150 divided by 136.118, and then times 40 kilometers. So, and then inverse sine, it's, so you have theta prime at 8.449 degrees. Now that is just the little angle in the triangle. That's not your bearing. What is your bearing here? The bearing here, it's going to be 90 degrees plus 8.449. So that gives you 98.449 degrees. Okay. So I would say in terms of difficulty, it's not really that hard. The stuff that it's being presented here, they're just asking you to use the tools that we have learned already. Okay. The fact is, make sure you are actually solving the problem, not just repeating some steps or procedures. You are actually trying to, you're actually trying to use the situation right here and get what you could get so that you can reach your final conclusion. Okay. So again, north is 0 degrees, 0 degree, east is 90, and so forth. Okay. So any question about how we use the old skills to actually solve problems? Okay. All right. So now let's go ahead and take a look on the next one. So the next one is not that difficult. Well, I mean, it's kind of easy to draw, but make sure you draw the crosshair first, so they can see how it is where it's heading to. So we will fly. Well, we'll an airplane. Oh, by the way, side knowledge. Do you know what is the fastest record to fly from New York City, JFK Airport, to London? What's the shortest time? It could take 6 hours, but that's not the fastest. That would be a little bit too fast. Less than 4 hours. Okay, and especially during winter time. Now, how many of you know there's a thing called jet stream? Anybody? It's the very strong wind that's blowing 150 miles per hour or even stronger, and it's even stronger during winter time. This weekend, it's going to be freezing again. Is because the jet stream is going down south, so bringing down the Arctic air. So you expect to have freezing temperature around 31 to 33 degrees at night for Friday and Saturday nights. Okay, so jet stream is very powerful. And if you dig up the history of jet stream, it's discovered during World War II when the fighter jets are flying over Japan to China. They discovered that, wait, I'm flying, but then my speedometer says I'm not. So then they just realize they are traveling against the wind. And by the way, speaking of traveling against the wind, we have a very technical term for that. Do you know what that is? If you are traveling against the wind. So if you are, this is an airplane and the wind is going in this direction, what do we call it? It's called a headwind. Okay, so we use this term to describe some struggles. Okay, if you are experiencing some headwind at work, and we're like, okay, feel bad for you. But what if you are on a very smooth sail that you are traveling with the wind? What do we call it? Tailwind. Okay, so a tailwind it is. Okay, so yeah, so that's so if you can fly so flying to Europe is usually faster. It'll be even faster if you can travel with the jet stream. Okay, last holiday, when my wife and I traveled from Chicago to New York, the flight was delayed to depart, but we made it on time on the arrival. And then I looked at the record. It says we are traveling at about 700 miles per hour. 700 miles per hour. Now, usually an airplane travels at about 500-ish miles per hour. So the wind is adding additional 200 miles per hour to the plane. So we are traveling at almost the speed of sound. So that was cool. That was cool. Okay. So an airplane flies 240 miles on a bearing of 25 degrees. So so you would point 25 degrees roughly and draw a big arrow that is 240 miles. Okay, at 25 degrees. And then turns and fly 160 miles along the bearing of 130 degrees. So I'm going to draw another cross right here. Okay, another cross right here. And that is turning to 130 degrees. So 130 would be somewhere right here-ish for 160 miles. Okay, and that is 130 degrees. What is the bearing of the airplane? How far is the plane from its starting point? So we are looking for the distance here. Okay, we're looking for this distance, or the resultant, actually. So I'm going to give you the first challenge right here. Can you tell this angle? Okay, using the clues that we have here, can you find this top angle? I can give you a hint. You are going to use something you learned from geometry about parallel lines. What is this angle here? Part of it is 25 degrees, but that's not 25 degrees. Now, so one thing about problem solving is that looking at what you have, can you tell something? So if you look at the 130 degrees, what can you tell? The other part right here, it's 50 degrees, right? So the other part, this part is 25 degrees. You know why this is 25 degrees? Do you remember this thing called the alternate interior angles with two parallel lines? Okay, like this is a parallel line right here. This is a parallel line right here. So so they are parallel to each other. So therefore, you got a 25 degrees right there. So all together is a 75 degree angle. Okay, so now you can go ahead and find out the distance. Okay, give you a minute to find out the distance here. So you should have x is equal to 160 square plus 240 square minus 2 times 160 times 240 times cosine of 75 degrees. That's x squared. All right, so you would add all of them together. 160 square plus 240 square minus 2 times 160 times 240 times cosine of 75 degrees. And then square root that number. So I've got 251.640 miles. Yes? Okay. So we got the distance, and now we need to find a bearing, which is from the north all the way to here. This is our big theta here. All right. So we are like, so how do we get this little angle in this case? Well, to find out the bearing, we need some help. We'll need the help of the triangle. So we'll need to find out this little angle right here, which is, it's called a delta, theta prime. Now, if we can find out the this little angle, theta prime, then we can just tag on the 25 to get the bearing. So we say, all right, so how are we going to find out this little theta prime? Okay, so we use the law of sines, and we will also use what we just calculated. Okay, so go ahead, sine 75 divided by 251.64 times 160. So we get 0.614 for the sine theta prime. And do the inverse of that. So the theta prime should be about 37.891 degrees, but don't be too excited. That's just your theta prime. Your actual theta, the bearing is 25 degrees plus 37.891 degrees, which is 62.891 degrees. 62.891 degrees. Okay, so nothing really new today. It's just using what we learned previously, law of sines, law of cosines. Okay, so pretty straightforward, easy. And then we have the back page. We have the back page. So we have a boat. That's traveling north for 35 miles per hour. So we have a boat right here, is traveling up north for 35 miles per hour. And then there's, is it a wind? The water is actually moving at 9 miles per hour at a bearing of 32 degrees. So now the way we would draw the arrow for the water, it's going to be like this. So at a 32 degrees, so somewhere like this. And not too long, okay? So this is like a little nudge, okay? So the water, it's nudging the boat to the east, and the speed of the water flow, it's 9 miles per hour at the angle of 32 degrees here, okay? So one thing that we can tell is that the boat is not going to travel at exactly north direction. So, but how do we know? How do we know what direction it's going to take? Okay, so we need to find out the bearing and also the speed. And now, should we just connect these two arrowheads together? Okay, should we do that? All right, so this is probably the most common mistake that I see students committing on this unit, because they just kind of join things together without looking at the context. So you would not connect these two arrowheads together because you're looking for the resultant. And what we learned on Monday about the resultant vector is that it has to be joined from head to tail. So we will duplicate the wind vector, and then we will go from the beginning to the end. So that will give us the overall vector and also the angle right here. So this is our bearing here. So based on this, well, we have this angle at 32 degrees. So this little angle right here must be 148 degrees. So if I want to find out what the overall vector is, we can just do x squared. It's equal to 35 square plus 9 square minus 2 times 35 times 9 cosine of 148 degrees. Okay. And then we can find out our x. 35 square plus 9 square minus 2 times 35 times 9 times cosine of 148, and then square root that. So you would have a total of 42.898 miles per hour, which makes some sense because you have a wind that's pushing you further. Okay. So you're not adding 9 to 35, but you're adding part of the 9 to the 35 because you're traveling, almost with the wind. So that is this part right here. Okay, the overall resulting speed based on the speed of the boat and also the water flow. And then we need to find out the bearing. And to find out the bearing, we can just do law of sine. So sine theta is to 9, and then sine of 148 degrees is to 42.898 miles per hour. Well, it's going to write the units get canceled out anyways. So sine of 148 divided by 42.898, and then times 9. That would be the sine theta will be 0.111. You take the inverse of sine of 1.111, you get 6.383 degrees. So this would be the bearing. Okay.